Today, we're diving into a technology that is literally aiming to completely redefine the backbone of the internet itself. We're talking about the Internet Computer Protocol, or ICP. Now, for years, the blockchain narrative has been entirely dominated by decentralized ledgers. And hey, they're great for tracking digital money, but that's essentially where it stops. ICP, however, is attempting something radically different.
Imagine for a second, what if a blockchain didn't just store data, but actually ran the entire internet? This completely shifts our perspective from basic digital ledgers to a proposed decentralized replacement for big tech's cloud computing. Just imagine a world where the app you use, the website you browse, and the back-end server running the whole shebang aren't hosted on Amazon Web Services or Google Cloud, but natively on a blockchain. That is the fundamental game-changing premise we're unpacking today.
So here's our roadmap for today. We'll start by looking at how ICP moves beyond traditional blockchains. Then, we'll dive into how the tech actually works, check out its goal of rebuilding the cloud, explore the push for sovereign AI, and finally wrap up with its tokenomics and extreme efficiency.
All right, Section 1, beyond traditional blockchains. To really grasp the proposed solution here, we first need to understand the sheer scale of the problem we're facing. There is a pretty stark contrast between the traditional web we use every day and this proposed Web3 model. Right now, our internet relies heavily on legacy, centralized cloud infrastructure. It's a system that needs constant, endless patching against a cybercrime industry that costs the world literally trillions of dollars. And while early blockchains decentralize data, they still rely on centralized servers for their user interfaces. ICP's documentation outlines a full-stack computing platform, aiming to host front-end, back-end, and data natively on-chain. This effectively removes the need for traditional firewalls, proposing an architecture that is just inherently more secure by design.
Moving on to Section 2, how ICP actually works. Let's take a look under the hood at the core innovations making this ambitious system possible.
So, the foundational building block of the internet computer is something called a canister. Think of a canister as ICP's supercharged version of a smart contract. Unlike traditional smart contracts that are limited to executing very small, basic pieces of logic, canisters bundle both code and state into one single, powerful unit. They're designed to be fully autonomous server environments. A canister can actually store data, perform heavy computations, and uniquely, it can serve HTTP requests directly to an end-user's web browser without needing any external trigger. This is exactly the mechanism that allows an entire app or website to live entirely on the blockchain.
But you might be wondering, if you're running whole websites on-chain, who is paying the network fees? If you've ever tried using a traditional blockchain, you know the absolute headache of paying a gas fee just to click a button or authorize a simple transaction. Well, ICP flips this completely on its head with a reverse gas model. Just like a developer pays AWS to host a traditional website, an ICP developer pre-funds their canister with computational fuel, which they call cycles. Because the canister pays for its own computation, everyday users can browse Web3 applications completely seamlessly, without ever needing a crypto wallet at all. The blockchain basically becomes invisible.
And that leads us right into another massive feature, chain key cryptography. This cryptographic engine is what ties the network's parallel subnets together and allows the internet computer to natively hold Bitcoin and Ethereum private keys. According to the source material, this creates a multi-chain environment right out of the box, yielding assets like SeekBTC and SeekETH. And the best part? It does this without relying on third-party, multi-signature bridges which, let's be honest, are historically vulnerable to some pretty devastating hacks. It proposes a true bridgeless integration.
Okay, Section 3, rebuilding the cloud. Let's zoom out a bit and see how this technology attempts to scale up and take on the trillion-dollar global cloud infrastructure market.
This massive shift is already being discussed at an institutional level. Dfinity representatives recently met with the United Nations Development Team and Blockchain Advisory Group in Paris to discuss achieving digital sovereignty for nations. As geopolitical tensions rise, countries are getting increasingly wary of relying on foreign big tech providers for their digital infrastructure. ICP's sovereign cloud capabilities propose a way for nations to host their own data on a decentralized network, keeping their autonomy intact. Meanwhile, tools like Caffeine AI version 3 are launching to allow seamless no-code deployment onto this network. That means developers can launch apps without needing to learn complex, entirely new programming languages.
Of course, to act as a truly global, decentralized cloud, the network requires some serious enterprise-grade performance. ICP operates on parallel subnets, and sources indicate each one of these subnets handles roughly 11,500 transactions per second, complete with a blazing fast 2-second finality. Theoretically, the network scales horizontally by simply adding more subnets as adoption grows.
Which brings us to Section 4, the sovereign AI revolution. Because beyond just hosting websites, ICP is positioning itself as a decentralized environment for artificial intelligence.
There's a powerful quote here. If you don't control your AI model, it's not yours. Right now, just a handful of massive corporations control the most powerful AI systems out there. They decide the training data, they control the privacy, and they dictate the outputs. This intense centralization creates some pretty major risks for bias, data theft, and manipulation. ICP proposes a totally new model, hosting and running AI models natively, directly on-chain.
Sovereign AI is designed to give developers and users actual ownership and control over their models. Because the AI is natively hosted on the blockchain, developers can establish totally transparent governance through on-chain voting. Plus, in a world that is getting flooded with manipulated content, having AI run on a cryptographic protocol means data and outputs can be verified for authenticity directly at the source. It proposes a whole new standard of trust for the modern internet.
Finally, we arrive at Section 5, tokenomics and extreme efficiency. Let's take an objective look at the economic engine running the network and, importantly, its environmental footprint.
The entire ecosystem is powered by the native ICP token, which basically serves three distinct functions based on the protocol's design. First up, governance. Holders can lock their tokens in the Network Nervous System, or NNS, to vote on network upgrades and earn staking rewards. Second, it acts as computation fuel. The token is converted into those stable cycles we mentioned earlier, which are then burned to power the smart contract canisters. And third, it simply trades as a standard digital asset on exchanges.
Now, to address the token's long-term economic stability, the project has introduced initiatives like Mission 70. This is a pretty aggressive strategic plan aimed at cutting the ICP token's inflation rate by up to 70%. As the network goes through a maturation process over the next few years, these measures are explicitly designed to mitigate inflation and stabilize the network's internal economy.
But honestly, to me, one of the most fascinating parts is evaluating its environmental impact. It completely shatters the stigma around blockchain energy usage. We can look at data from the 2026 Crypto Risk Metrics Sustainability Report, which ensures compliance with strict European regulations.
When you look at the annual energy consumption, the visual contrast is completely staggering. The report notes Bitcoin consumes 139.5 billion kilowatt-hours, and Dogecoin uses 4.7 billion. By comparison, the Internet Computer Protocol is recorded at just 5.8 million kilowatt-hours. It literally uses a microscopic fraction of the energy consumed by legacy chains.
In fact, the data claims that when compared to traditional centralized legacy data centers, ICP boasts up to a 95% reduction in overall energy consumption. This extreme efficiency is reportedly achieved by placing the protocol layer directly between the user and the data center, cutting out all the resource-heavy intermediaries.
So that brings us to our final, overarching question. Will ICP become the new backbone of the internet? The source material outlines a massively ambitious vision here, from decentralized cloud capabilities and natively hosted AI to extreme energy efficiency. This technology is deploying worldwide, aiming to solve multi-trillion-dollar problems. If these metrics hold up, the question isn't just whether a blockchain can run the internet, it's whether the shift has already begun without us even noticing. What do you think? I really hope this explainer gave you a clearer picture of this proposed paradigm shift. Stay curious, keep learning, and we'll see you in the next one.